Hello everyone, I'm Erin from WebNazar, your digital lens on everything trending. Today, we're diving into another important story, idea, or innovation shaping our world.
We have reached the limits of the chat box. Enterprise infrastructure is evolving beyond single-turn language models and towards autonomous, multi-step agentic systems. Generative AI is built to be stateless and reactive. You enter a prompt, the model processes the text, and it returns an output. It waits for human instruction at every step. Agentic AI operates differently. It runs on a continuous loop of perceiving context, planning a sequence of actions, and manipulating external software to achieve an objective. This structural difference shifts the risk profile. The primary failure mode for a generative model is informational risk, producing a biased summary or hallucinating a fact. The primary failure mode for an agent is operational risk, executing an unintended action across live business systems. Managing these live operational risks requires a structural overhaul. Prompt response models work for generating text, but they lack the mechanical intercepts necessary to safely govern autonomous action. There is an engineering assumption that if a model undergoes enough reinforcement learning from human feedback, it can be trusted to act safely. But that alignment happens exclusively during the training phase. It cannot account for the unpredictable state changes an agent encounters when chaining commands across a long time horizon in the real world. To intercept errors as they compound, developers are introducing a runtime human-in-the-loop orchestration layer. Oversight has moved from the training phase to the point of execution. This is live governance, occurring while the system is in motion. Human-in-the-loop orchestration serves as an integral engineering routing layer. If an agent operates external tools, this oversight is required to ensure autonomous safety. This diagram illustrates the baseline topology of a standard language model interaction. A single input triggers a single output. In an agentic framework, that input node becomes a supervisor. You give it an open-ended objective, and it begins planning. The supervisor immediately breaks the goal into subtasks and spawns specialized subagents to handle each component. These subagents query vector databases and search external APIs to gather the necessary context. Once they have the data, they execute. They push write commands back out to external applications, altering the state of those systems. This architecture scales complex problem-solving efficiently, but it buries the logic deep inside the system. State changes happen continuously without direct human visibility. That lack of visibility creates the conditions for a cascade failure. Suppose a subagent misinterprets a single data parameter during a routine API query. It passes that corrupted variable to the next agent in the sequence, which accepts the input and proceeds. If you query the language model's internal confidence metric at this stage, it will likely report high certainty. Models are notoriously miscalibrated on long-horizon reasoning tasks. Operating on false certainty, the agent pushes a destructive write command to an external application, triggering an error cascade across the network. When autonomous systems are allowed to call tools without friction, an edge case failure becomes a mathematical certainty. The solution is to distribute human oversight across three specific phases of execution: pre-execution, in-execution, and post-execution. This routing matrix illustrates the 5-tier action taxonomy, a decision tree that determines exactly when an agent needs permission to act. Tier 0 covers read-only